Myself Surakar Vedant Dattatri. So I'm today our topic is turn off and turn off transistors analyzing using SCR simulation. So our group members are Kavage Abhiraj, Sarthak Pawar and Sarthak Pawar. As our objective is to simulate and observe the turn on and turn off the thyristor of silicon control rectifier SCR to understand and dynamic behavior of SCR using switching operations to analyze the voltage current waveforms during the triggering and common commuting process to study the factors affecting switching time and device performance. As introduction, a silicon rectifier SCR is of 4 layer, 3 junctions. As semiconductor device used for controlling power, AC and DC circuit. It acts as a switching, allowing current to flow only when triggered by a gate pulse. As the SCR has two input switch process, turn on transistor. The period during the which is STR transistors form of blocking state or to on conducting state. Turn on transistor. The period of during the which SCR return to its off stage after a condition.
My name is Sarthak Pawar. So I'm going to explain working principle of turn off and turn on SCR. So when a suitable gate current is applied to gate terminal while the SCR is forward bias, it start the conduction process. Initially, the SCR is in the forward blocking state. The anode is positive with respect to cathode, but no current flow because the junction J2 is reverse bias in forward blocking state. On applying the gate pulse, the middle junction J2 break down, allowing anode current to rise sharply. During this transition, the current and voltage waveform show a transient period until the SCR reach steady state condition. In this process, the voltage across the SCR drop from a forward blocking voltage to a small on state voltage, typically 1 to 2 volt. So next point will explain by Sarthak Pawar.
So hello everyone, my name is Sarthak Pawar. This is my simulation. First we are get the AC voltage source to run supply the circuit. Next we get the 4 thyristors and 4 get pulse generator. And next we are in pulse generator we are taking the value. Aptitude is 1%, period is 1 upon 50%, and pulse phase delay is A into 0.02 divided by 360. And next one we are get the load R load. This is the 10 ohm resistance, and branch branch voltage is taken. R load branch voltage is taken. Next we are connect 2 thyristor value is same, and another 2 thyristor value is same. Next we get the multimeter to measure the all scope, measure the value. Next we get the scope for measurement of the waveform, and then start the run the waveform, run the simulation.
So this is our simulation, and now we are run this simulation. First we connect all the circuit in proper, then we are run in scope time 0.10 second, and this is the scope value. This is a waveform of positive cycle and negative cycle. This yellow line gets positive cycle. This is run by positive this path, and this is the negative end point, and this blue line indicate the half cycle, uh, that is positive to negative, and
My name is Abhiraj Kalage. I am going to explain applications and conclusion. First one is application. Power control AC circuit. In silicon control rectifier is widely used to controlling AC power supplied to the load. So, by adjusting the firing angle, the average voltage across the load is varied. For the example of this, light dampers, fan speed control, heater control circuits, and rectifiers. As we know, rectifiers is convert AC to DC. So in silicon control, it can be used. The output uh, voltage is controlled varying the gate triggering angle. When the triggering angle is turn when the triggering angle is changing, ACSR is turn on. And some example, DC motors in industry and battery changing system. Next slide is conclusion. The conclusion: the simulation of turn on and turn off transistor silicon control rectifier helps to understanding dynamic behavior of the device during the switching operation. During the turn on process, the ACSR transistors from non-conducting forward blocking state to conducting state when the suitable gate pulse is applied is showing the rapid rise anode current and sharp drop voltage. During the turn on process, the ACSR remains blocking capably on after the change carries recombine, which define the turn off time.